So, several months ago, do a lot of things at Microsoft with SQL, edge to cloud. One of the coolest things I get to do is work with some of the smartest people on the planet on really cool projects. I remember Dimitri Furman reaching out to me saying, have you seen this thing called Database Watcher? No. What is it? We start talking about it. I said, oh, this is Perfmon in the cloud. He's like, that's a good name for a session. Hey guys, I'm Bob Ward from Microsoft. Are you powering through this day here a bit? Are you powering through it? I just saw tea time with cakes. Might be taking a nap now if you had a cake here for tea time. So, you may have saw in the keynote today this technology called Database Watcher. I'd like to introduce, special introduction, to the person who literally is working on this technology, plus one of the deepest experts we have at Microsoft on SQL, Dimitri Furman. Dimitri, tell everybody about yourself.
Hi, everyone. I'm Dimitri. I'm one of the PMs on the SQL team working on monitoring. And today we want to talk to you about Database Watcher, our new monitoring solution for Azure SQL. So just to give you some background, I've been at Microsoft for more than 15 years, and most of this time was spent working on customer performance issues, troubleshooting, monitoring, what have you, and there is always has been this one challenge, getting data in one place and getting historical data. It wasn't easy. So that was the main motivation behind Database Watcher. We want to collect this data, we want to collect detailed data, put it in one place, and expose it in Azure Portal. So that's what we did, and that's what we will talk about today.
And you're such for a treat because Dimitri is so humble. Not only is he working this project, but if I have questions like an Azure SQL Database, I ping Dimitri going like, how does this work? Well, Bob, let me tell you. And I get this really complex discussion. I love talking to really smart people. Hey, some logistics for you. You are probably wondering, it would be kind of cool to get this presentation right now. aka.ms, bobwardms. That'll be on the last deck that we had slide today as well. The slide's already there. Our demos are recorded, but they're in the deck. So you can go back and get the deck, download it, and go watch it yourself after the fact. We also know you're going to have some questions, and we want to answer those questions. We're going to pause intentionally right after some demos to take a lot of questions about what we've shown at that point. We're going to do that. And then at the end, we'll do some more questions. And at the end, as you can see on this agenda here, we're going to talk at the end more about pricing and roadmap and timelines and actual frequently asked questions we've heard people talk about during the private preview. So reserve those questions near the end. But let's take a moment specifically, and look at this, Steven's got the handheld mic here. Let's see how far we make Steven run around this room when you ask your questions. But for those online, we are also going to pause and make sure we answer your question for these guys watching as well. Okay, so, sorry, real quick here. I wanted to point out, Dimitri and I put this on our slide. Take a note of that site right there. Dimitri is an extremely thorough, hardworking person. So he beat us to it. He already has the documentation, the blog post, everything is out there for you to read about as well. So AKMS DB Watcher is a single spot where you can go to after you're done here learning this. You want to go back to your company and dive in and learn more about this technology, especially how to go enable it in your Azure environment. Okay, so you saw this perhaps in the keynote, and keynotes are tough because we're just flying, right? We're trying to get as much as we can pack into a single session. But you may have heard me say the following. It's a separate managed service. Dimitri's going to show you the architecture, how this works, how do we connect, where does it run, but it's a super comprehensive monitoring solution. Again, you're thinking about the knowledge of somebody like Dimitri, people like myself, trying to go in and figure out what would we want you to be able to see in the job you have in managing these properties. I myself set this up, and it is very easy to configure and set this thing up. I found it very, very simple. I think you're going to find the same thing in that process. And here's the cool part. Near real-time latency. I want to see stuff now, what's going on in this environment. But what we don't say is historical. How do you make that powerful combination of having near real-time information live about your system, but also get the history you need to go back and look at trend analysis? And the way we achieve that is through showing you dashboards in the portal. However, there's some more information you should know about what we're doing. Has this been easy for you to do? In some cases, people write scripts. They spend a lot of time going through the process of trying to go figure out how to go get these things. But how do you get these things in one place? How do you do things like even historical and current query sessions, and how do you do this across databases? You saw talk about that this morning in the keynote. So this map shows you just part of what's possible to do with Database Watcher. And the key thing to think of as you're looking at this is not just for a database. This is not just for an instance. This is across multiple properties that you have to go look across these at scale. And the way we can achieve that is because we're storing this information in a different location that gives us the power to go put those things together. Now, what does that look like? It looks like this. Number one, we have something called targets. You're going to see Dimitri show this in a second, which means today, and this will be expanded more in the future, we can do databases and managed instances. And notice here we have different types of combos of things we support, whether it be pools, hyperscale, even replicas, or serverless to go manage. So the targets are the thing that you're going and collecting data about. Second of all, it's remote. So we don't run these things in your cluster or in your instance or on your server. We have a separate agent doing the actual collection, which makes it super lightweight. It doesn't affect the workload you're running in these applications. And look at the data sources. Dimitri has spent a lot of time talking to customers, going through what our knowledge looks like, to go through a rich set of what we call different data sets for these target types. And look at over 70 plus different views. And here's the thing I love about this technology. It's not like we made up stuff new. We already have the telemetry in the engine and in the cloud to go surface these things. We're just finding a very unique way to go to these sources and collect this information in a rich way for you to visualize it. And you're going to see later, even query this information. Now, we know you need authentication, so we have all of the things you need. You can use Entra, or you can use SQL authentication, but you need some keys and secrets to do that. So you have either combination to go connect and make sure that the service has authentication to what you've secured in the cloud. In addition, we want to make sure that you're fully protected from a network perspective, so we have private links or even firewalls with network security groups. So already out of the gate, you can see we're designing a service that feels like what we've already done for other Azure properties. This isn't just thought of and just, oh, let's go add that later. Out of the gate, we're already doing things to make things secure and run in a lightweight way and run in a way that gives you the proper authentication for protection you need because you control the security of your assets. Now, what we've done out of the gate, and you saw a little bit in the keynote this morning, and you're going to see more demos from Dimitri, is this kind of single pane of glass across these assets. You saw a heat map we showed. You saw us kind of go through various tabs to dive in and drill into various things. So we call those dashboards. We can drill into them. I love the idea of showing things at a higher level and then using drill-in capabilities. So out of the gate, we already have those visualizations. But the feedback we received is, that's great, but I may want to do things in a slightly different way. So we are storing this data in Kusto clusters out of the gate. So you can use Azure Data Explorer with things like KQL, even the ability to use a free Azure Data Explorer if you'd like to collect this information. Or how about Fabric Real-Time Analytics? That can also be a data store because guess what? They have Kusto databases. So if that's your preference, you want to put it there, do Power BI, other analytics in the Microsoft Fabric, you can actually go do that. So having this separate data store experience gives you the customization you need to query it in addition to what we're showing from this single pane of glass. This represents the landscape of what we're actually trying to build to give you this capability of doing analysis. And again, analysis can be near real time or historical. So that's really interesting, but I think you'd rather see this. So Dimitri, why don't you start diving into some demos, and then we'll stop and ask some questions.
All right, thanks, Bob. All right, so first, let's take a look at a demo. This is our estate dashboard, the at-scale one. So here I have an environment with some SQL databases, SQL Elastic Pools, managed instances. I can click in each one of those tiles and see the assets I'm monitoring. So you see some business-critical databases, general purpose, hyperscale. All of them have 4 logical CPUs. We monitor both primary and secondary replicas, as well as geo-replicas. Now what I can do at this point is just click on the database link to drill in. But first, let's look at the estate dashboard. So that's it. So I'm going to focus on the last half an hour. And what you're looking at is a CPU utilization heat map. Now, I am running a workload. This is just HammerDB standard TPCC benchmark. I'm running a workload, and we can see that there's some different degrees of CPU utilization. The same workload in all of those databases with 4 CPUs. And we can see that for the business-critical database, it's at about 80+%. For hyperscale, much lower. So there is some extra headroom for other workloads on hyperscale. There are similar heat maps, not just for CPU, but for data, or log write, workers, all the usual metrics, as well as batch requests per second. So again, you can drill in and take a look at individual databases, and Hyperscale and Business Critical in this case are kind of head-to-head. Hyperscale a little bit ahead of Business Critical, and then we'll see why. Now, we can also look at a heat map of weights. This is weight types. And this is just total cumulative weights, but I can also filter this by a weight category. And let's, for example, focus on replication weights. This is availability group replication. And we can see that for the business critical database, it's actually significantly higher because, as we know, business critical uses availability groups for resiliency, redundancy. Other things you can see is the storage area heat map. So this is where you can see things like latency, IOPS, throughput separately for reads and writes. What I'm going to focus on is write latency for transaction log, right? And that's because this particular workload is very write intensive. A lot of small transactions write into the transaction log, so log latency, log write latency is critically important to achieve great performance. Now, if we look at general purpose, we see latency about 2 to 3 millisecond range. For hyperscale, it's much lower at 1.2. And for business critical, it's actually in microseconds, 200 microseconds. So you would expect that for this workload, business critical would far outperform hyperscale, and yet that's not the case. And later in the next demo, we'll see why, because Database Watcher gives us enough information to tell. Okay, next, let's look at top queries view. So as Bob mentioned, this is query store data we collected from multiple databases, all databases in the estate, into the single data store. Each tile here represents a query that may be running in multiple databases. I can click on the tile and then see things like query text, obviously, query weight categories, query ranks. So this query is number 1 by CPU. It's also number 2 by number of executions, number 3 by logical writes, and so on and so forth. You can drill in and see how this query performed in each individual database. So again, this is standard query store metrics. And you can also see plan level information as well. In case there are multiple plans, you can see how different plans perform. Other things you can see here is the top databases view. And again, this is ranked by CPU, so you can see how much CPU each database uses, but you can also rank it by all other query store metrics right here, what have you. So other things you can do, you can filter this by execution type to maybe only focus on failed queries instead of all. You can filter by databases, and you can filter by query text, by fragments of query text as well. So another thing I can show here is the data ingestion latency, right? So we are looking at the last 30 minutes, and we can see that at 90th percentile, we are ingesting data in less than a second, right? Less than half a second. And even if you look at the maximum latency, it's still single-digit seconds. So data gets into the data store very fast. All right, so that's the first demo. This is the state dashboard. But let me go ahead and actually show you how this looks on the detailed dashboard if we drill into a specific database. All right, so starting from the batch request per second heat map, we are going to drill into the Hyperscale database first. And this is a detailed dashboard. So you can see, for example, things that it's a Hyperscale database. It's specifically a premium series Hyperscale with 4 logical CPUs, 20 gig of memory, supporting up to 100 terabytes, all of those details. It's a primary replica. And then on the performance tab, you start by looking at all the usual metrics. You have this in the portal, but we show it here as well to have all data in the same place. Then you have a chart for batch requests per second, distribution of request by time bucket, weight stats. Now, if you look at the weight stats in greater detail, we see that most of the weights are specifically on write log. So, and it's not surprising because we are running a write-intensive workload with a lot of short transactions. And the total wait time is a little bit less than 2 seconds, right? Now, let's compare this against the business critical database. So I can switch to the business critical database right here from the dropdown. And if you look at weights, we see that write log weights are actually much lower. It's about 700 milliseconds, right? So you'd expect that this would perform better. But remember, this is availability groups. So when a transaction commits, it incurs not just the write log weights in the local replica, but also the overhead of synchronization. So HIDR sync commit weight is about 1.7 seconds, and together those weights are higher than 2 seconds that we saw. And that's higher than what we saw for Hyperscale with less than 2 seconds. And that's one of the reasons Why Hyperscale outperforms business critical in this case, the other reason being extra CPU headroom that you saw on the first heat map. Also on the same dashboard, you see a bunch of different charts for common performance counters. That's just a subset of all performance counters we collect. There is more than 200 of them. So this is just the most common. You can see memory details, transaction details, replication details, and so on and so forth. Other thing you can do here is look at activity, right? So this is basically a snapshot of query activity that is occurring right now. If you look at the sample age, it's 8 seconds ago, right? So you can see what queries are running at this point in time. You can click on each query to see details, such as input buffer, statement text, session wait stats, all other request and session details. But this is current. What if I wanted to look at this historically, right? So I can click on the historical view and pick a point in time in the past. And this time, I'm going to look 2 weeks in the past. And I can pick a point in time, but let me focus specifically on samples that have some blocking in them. So that's one of those orange bars. If I click on one, I will see that there is some blocking, right? And we can focus just on blocked and blocked processes and see that there is indeed some short-lived transient blocking. And we see the blocked process and blockers right here on the screen. Moving on, sessions. This is cumulative session statistics over time. You see user sessions, you see CPU, elapsed time. But what's more interesting is the ability to break it down by login, host, or program. So you can see how different applications consume resources. I'm going to skip over top queries because that's the same view that we saw before, but specifically for this one database. On the storage tab, just like what you would expect, storage utilization, storage consumption details over time, you can see that, for example, used and allocated data has been climbing up over the last 14 days, so that's a trend. You can also see things like storage I/O statistics, IOPS throughput latency over time, separately for reads and writes, so very detailed data. Next, let's look at tables. This is the schema details. So again, this is standard TPCC schema. So you can see all of those tables here. You can see the number of rows, how much space they used, partitioning information, compression information, allocation data. Clicking on each row, of course, gives you more details. And then indexes, so similar kind of data. And for indexes, we also collect operational statistics, so you can see how each index is used. So if you look at those red and blue bars, you can find how, if an index is being just written to or actually used for reads. And if you look at the specific index, you can see it's been mostly updated, but not used so much. Because there is a warning that it's basically may not be that useful, right? And the second warning that you will see is about page locks. So page locks are disabled on this index, which is not a best practice. Connectivity. So Database Watcher runs connectivity probes just to establish that network connectivity to your databases is healthy. So in this case, there was one failed probe about 13 days ago. And you can see that it was transient. So about 37 seconds ago, the probe succeeded, then it failed, then 22 seconds later, it succeeded again. So probably a failover, short-lived failover. Geo-replication, so we monitor that. So things like geo-replication rates, log send rates, partnered information about catch-up state, and so on and so forth is available. Backups, so just like what you would expect, this is a summary of all the backup information, backup statistics, individual backup operations, how long they took, what was the interval between backups. So all of this data that's available in DMV is just visualized on this dashboard. And then finally, you see all of the configuration properties of this database. So things like database code configurations, engine start times, database create times, as well as all of the database options are available on this view. All right, so we got to the end of this demo, and next what I will show is how we can actually query this data ad hoc, right? So that will be the topic of the next demo. All right.
Dimitri, that was crazy. Is anybody's head kind of blown away a little bit from all of that information? It's information overload a little bit, right? So that's on purpose. The purpose part is that we don't want to leave anything out. In fact, Dimitri, I have a couple of questions before we take from the audience. So you showed a ton of information. Do you document like kind of the data you're collecting across this?
Yes, in detail. So if you follow that DB Watcher documentation link, that's in one of the articles. You'll find details on what we collect, how frequently we collect it, and so on and so forth.
Yeah, so if you know SQL, or if you know a little bit about the cloud, you can find out behind the scenes, like what are you guys querying, or what are you seeing, and so forth. Right. The other question I have is that what about performance impact maybe to the apps and workloads to use this?
So very minimal. In Azure SQL Database, all of our monitoring queries are resource governed to consume a very small portion of all resources. On managed instance, you can use resource governor for the same purpose as well.
Oh, awesome. Now you showed several different resources. So is it true I can actually go monitor across, like in my whole dashboard, I can do MI and databases all in one thing?
Yep.
Okay, that's pretty crazy. So
and elastic pools as well.
And elastic pools as well. Okay, that's nuts. All right, so let's see what kind of questions you have. Let's start in the audience first. Stephen, you have the mic. Let's hear what you have to say.
I was wondering if you can monitor Azure Database between tenants.
Between tenants. So we can monitor across subscriptions. If you have two different tenants, you'll have two different watchers in each tenant. They don't have to be in the same subscription, but they have to be in their own tenant.
So you need a watcher per tenant to manage across subs.
Correct.
In each tenant. Okay. What are the questions? Way in the back. We're gonna have to look this way because the lights are blinding. But yeah, go ahead.
Hi, Bob. Similar to my Copilot question, is this coming to Azure Arc?
The question is this a coming to Azure Arc?
So today we are focusing on Azure SQL first, right? And we'll look at the roadmap. Our next target is SQL Server and Azure VM. What comes after that depends on your feedback, folks. So please tell us how you would like this to develop. We have feedback details in documentation. So that will be driven by feedback.
So real quick, so in the documentation in DB Watcher, if I have, because it's public preview.
Correct.
But if I want to give that feedback, we have some information at the end, I think, for you to send emails to, but also in the Watcher docs, there's a way to give us feedback.
Absolutely.
Yeah, okay. Right here.
So it's great having the monitoring and the dashboards and the data there. How about alerting, which you care about more in large estates when you're breaching thresholds?
Alerting.
So again, we'll talk about the roadmap. That's one of the top items.
Okay. Checks in the mail. Right here. And then we're going to go online. Nothing online right now? Okay.
The read replicas, will data be collected from them as well?
Read replicas.
All replicas are supported. All kinds of secondary
Now that's
replicas.
pretty cool. I love that question because I hadn't thought about that. So I can actually go see how the read replicas are doing as well. Like, are the read replica queries running as well as they could be like on the primaries? Oh, that's sweet. Some of the questions in the audience. Steve, do you have your own question?
I have
Please.
my own question. Will you be supporting Azure VM?
Yes, short answer.
Thank you.
Absolutely. I mean, one thing in general, I would just say, and we got the same question in the Copilot session, we do sometimes start out exactly in the cloud in a space like that, but it is our intention, based on your feedback, if we can go edge to cloud in these kind of type scenarios. So yeah, VM is on like your radar, I think. That's on the roadmap to at the end. So is there online?
From Kevin Morris. The documentation says this is not available in UK regions yet. When do we expect that? Corporate won't allow us to use resources outside the UK.
First of all, I'm impressed that they're already looking at the docs, Dimitri. But yeah, do you have any comment about region support?
Thanks, Kevin. Great question. So as it happens, we are deploying this in UK South at the moment. So
look at that. So Kevin, maybe tune in like in an hour. No, I'm just kidding. Yeah, but we're actually deploying the UK right now. So
yeah,
other questions? Go ahead, Dimitri.
Regional availability will be expanded. Right now, it's just a few regions, but over the course of public preview, you should see it in more and more
Do you list the regions in the docs, Dimitri?
We do, and one thing that if you don't have it in your region, you can actually monitor cross-region. So the watcher and your monitor databases do not have to be in the same region.
Okay, so let me make sure I'm clear on that. My watcher could be in a region, and then my database in a different region. So your region support in the docs are about watcher region support.
Correct.
Is that right? Okay,
Correct.
Makes sense. Yeah.
What's the ETA to release Database Watcher to general availability?
We'll have a separate slide on that.
Roadmap slide at the end. Yeah. Oh, that's your question. Okay. And I'll keep Dimitri in check on that one to make sure that he doesn't get too aggressive in telling everybody when GA is. Actually, he's worried more about me. Yeah.
how frequently this is picking up the information.
Oh, good question.
All right, so great question. So it depends on the data set. For some data sets that collect frequently changing data, we collect every 10 seconds. For data sets that collect mostly static data, like database properties, for example, then it's every 5 minutes or thereabouts. So it really depends on the data set.
Yeah.
And it's documented as well.
And to be clear, what I was seeing you showing there, what I loved about this, like by default, I have history. So I can go back, like if I had an outage or an incident or a problem with my app, I can literally just go back to that point and say, well, what was going on at that point in time? That's just beautiful. Way at the back, Stephen, you got another one. Sorry.
I'm sorry, one more question.
Yeah.
When are we expecting to go this for the GA?
So the GA question got asked already. We'll talk about roadmap at the end. So we'll take another one from the back there. I think we have some more time, Dimitri, to get some questions in. Okay.
So my question is about resiliency. So are there situations where the agent or the data wouldn't be able to be reported? Maybe disconnection, or what happens if the
resiliency of the watcher data?
Yeah, the watcher. Yeah,
okay.
It's the watcher itself.
Yeah.
Right. So it's running on a highly available infrastructure. So if a single instance of a watcher terminates for any reason, we'll start another one.
Awesome. Okay. Anything else online? Okay, we'll come back for questions at the end. Dimitri, I'd like you to talk a little bit more. Some questions were asked already, but let's a little more about the architecture.
Yeah, let's take a look at how this works. So here you have your Azure SQL estate, and that's a mix of various databases, managed instances, elastic pools. Now, what you do, you create a watcher resource, initially in a stopped state, and each watcher has an identity. This is system managed identity, and you can use this to grant it access, specific limited access to your resources, right? Next, what you do, you select a data store. And as Bob mentioned, the data store can be Azure Data Explorer, the free flavor of it, or real-time analytics in Fabric. Collectively, all of those things known as Kusto. So I will just say things like Kusto Cluster, Kusto Database, because they all run the same core engine under covers. So what happens next? You identify a set of targets. A target is basically a resource, an Azure SQL resource that you want to monitor. You can monitor your entire estate. You can pick and choose specific ones. Next, and that's optional, you can create private endpoint for private connectivity. We expect that most folks will use this. But if you don't want to use private connectivity, it will still work with public connectivity and NSJSON firewalls. And at that point, you'll start the watcher. Now, if you use SQL authentication, there is an extra step. The watcher will connect to a key vault and grab the credentials that you've given it to collect monitoring data. And then it will basically connect to all targets, and the data flow will start from targets into the data store and onto dashboards. And at this point, the data is also available for ad hoc, on-demand queries. So in a nutshell, that's how it works. It's a very simple pipeline. That's what kind of gives us the low latency, near real time. And the data is available, as we saw, in seconds. So what I'd like to do next is talk about network and data access. So we have basically three principles here. So you as a customer fully control network connectivity and permissions at all times. We require just minimal access to customer databases. And what we actually do at connection time, we'll check the permissions that we hold. And if they are accidentally higher than what we need, we'll disconnect. So we don't want at any time to have more access to your database than strictly needed to collect the monitoring data. And you can see on the slide what the permissions are. For network access, similar principle. So watcher supports managed private endpoints. And what this does is, as you configure the watcher, you create a private endpoint, but then the resource owner of logical server or managed instance or key vault or Kusto cluster will have to approve that private endpoint. And they retain full control over the lifetime of that private endpoint. So if they want to stop monitoring, they can always just delete the private endpoint, and at which point the watcher will stop. So next, let's take a look at the data that we collect. So what you see on the slide is dataset categories. In each category, there is maybe one, maybe multiple datasets. So you can see it's a fairly large and detailed set of data from active sessions, which we saw in the demo, to memory utilization, to index data, network connectivity, about 200 performance counters, query store data, of course, replication, basic resource utilization, properties and configuration, so on and so forth. So storage details, both in terms of I/O and in terms of actual utilization of space. Wait stats. Now, the good thing about this is that this is not a fixed set, so we can add more data sets based on feedback, and we have done this during private preview. So if you find some data that we are not collecting today, please send us feedback. It's actually fairly simple for us to enable additional data sets. So next, I'd like to talk about using Kusto for SQL monitoring data. So what is Kusto? So it's a specialized, special purpose data store for telemetry data, for log data, for time series data, and for doing large-scale analytics on the data. So it's perfect for this scenario. A single Kusto database can scale to support data from thousands of SQL monitoring targets, right? You just scale up your cluster or scale out your cluster as needed. So both vertical and horizontal scaling are supported in Kusto. You can configure data retention both at the database level and at the individual table level. So you can keep data in different tables for different periods of time. But most importantly, it's time-proven. It's time-proven because internally, Azure SQL Database and SQL Managed Instance uses Kusto to monitor all of the million databases we have worldwide. So, and we've been doing this for many years. So we know this works as a data store. So the KQL language that Kusto supports is very powerful for this type of analytics. The data is highly compressed, so very efficient storage in column store, same as SQL Server. But we also support streaming ingestion with low latencies to give you like this near real-time monitoring. For SQL customers, the learning curve is actually pretty short. Kusto uses the same relational database concept. You have tables, you have columns, you have queries that use joins, aggregations, projections, restrictions. So the language is different, but the concept is the same. Now, the best thing is it actually supports the SQL. So you can connect to a Kusto cluster from Management Studio and run a T-SQL query on this data. So that's something I would like to show in the next demo. All right, how are we doing on time?
SQL query, we're doing good. Wait, okay. Did you just say SQL querying on the Kusto data through Management Studio? Okay, I got to see that one. Right. I didn't know you were going to show that.
Okay, so
you're doing great on time, Dimitri. Go for it.
In this demo, so I'll start by showing some KQL queries, but then we'll see SQL as well. So here I'm looking at a database on a Kusto cluster. So you can see this is the same database that was used for the dashboards we just saw. And you can see that there are 3 folders for databases, elastic pools, and managed instances. I can expand one of those folders and see individual tables, and each table corresponds to a data set, right? So there is a little eye icon that gives you a tooltip describing the data in this table. So we can take a look. Now, before showing the data that the watcher collects, let's actually run some KQL queries to show the capabilities of this cluster. So .show cluster command. So what am I dealing with? So this is a 2-node cluster, 2 rows in this table. Each node has 4 CPUs, 32 gig of memory. You can also see the startup time of this cluster. So that's how you can tell how much resources your data store has. Next, let's look at all the databases on the cluster. So we see the database list and the total size of the database. This is compressed data. Next, let's look at size per database. So we see all the tables, and we see 2 columns, original size and compressed size. So if you look at one of those tables, look at the original size. This is almost 300 gig, but it compresses down to 3 gig. This is more than 80 times. Very efficient column store compression. OK. So next, let's look at .show queries. So this is a very handy command, and this is basically a query store for Kusto queries. You can see all the queries that were executed on this database. Those are actually dashboard queries that we've been running. You can see when the query ran, how long it took, how much resources it consumed, which application issued it, and if the query fails for any reason, you'll see the failure reason as well. So next, let's now start looking at the database watcher data. So this is a database resource utilization table, and I have some parameters that kind of narrow it down to a particular logical server, database, replica type. And you can see all of those filters are in where clauses. You can have multiple where clauses in KQL. So, and then there is a project clause, which is the equivalent of a select in T-SQL. That just narrows it down to a set of columns. And finally, we sort this data by time and render it on a time chart, right? So right in the query, you can create a time chart. So that's how this looks. So this is your time chart of resource utilization, CPU, data, I/O, and so on and so forth. But you can also see this data in a table as well. Now, let's see if we can do this in T-SQL. Here's Management Studio, and I'm going to connect. And what I'm connecting to is actually a Custo cluster. So you can see that you have to use Microsoft Enter authentication, but this is a Custo cluster. This is a query URL. So let's connect. And now you have your standard T-SQL query, same table, SQLDB, database resource utilization. Choose the database. And let's run this. So you will get the same data. You don't get this nice time chart. That's not an option in SSMS, but the data is there. So you can just query this data at will. Next, let's look at the different queries. This is database properties for all monitored databases over the last 24 hours, right? So this is slightly more complex because I have to do a self-join here. I have to basically get the latest sample of data from this SQLDB database properties. And that requires a self-join to find the maximum time of the last sample. OK, so let's run this. And we get basically the entire environment. This is every database and every replica of a database, I should say, that we are monitoring, right? And you can see things like service tier, service level objective, number of CPUs, and so on and so forth. How would this query look in KQL? So let's switch back. And this is the same query, so you can see same table, but now it's much simpler. Because in KQL, you don't need to do that self-join. So there is this very handy function called rmax. Summarize is the equivalent of group by, and what this does, for each unique combination of logical server, database name, and replica type, it finds the latest or the maximum sample time UTC. And that's the row that it will return. So it returns that basically the latest row in a group and all columns in that row. So no self-join needed, much simpler, and then we basically just return the results. All right, so you can see it's the same data set that we saw before. All right, next, can we look at top queries? So basically same data as we saw on the dashboard, but returned by a query. So that's the query. And by the way, all of the samples I'm showing are in documentation, so you can just run them yourself. So this is a query that returns data from a particular database or a logical server. Oh, I'm sorry. This is weight stats. OK, so that's weight stats query. This is top weights. And we can see this is right log weight as we saw before over time. So you can see some spikes, some dips. Now, next one is the top 10 queries, right? So this is where you can set filters by type of ranking. So this is by CPU, but you can, again, choose any other ranks. You can select the number of top queries, time interval, filter by specific database, logical server, so on and so forth. So it's a long query, but again, it's in documentation, so you can just copy-paste. So let's run this. OK, and that gives you top 10 queries by CPU. Right? So you get the query text, you get all of the query store metrics, execution stats, number of executions, CPU, duration, so on and so forth. And ranks. So you can see that it's ranked by CPU, but all other ranks are available as well. So that helps you find top queries. Can we do this in T-SQL? Yes, we can. So again, same query, top 10 over the last 24 hours. This is a little bit longer query, verbose, because we have to look at every query store metric. But if you run this, then you get the same result set. All right, so that is the end of this demo.
Dimitri, real quick before you go on. My gosh, like a head's exploding. So just double check here. You're going to get the deck so you can see you do the demos. But are you saying that in the documentation you have the sample queries for this stuff?
Same queries.
Oh, man, I love it. So then you guys can use this as templates to move forward and kind of use this and do it as well. Great, we're going to take questions at the end. We'll do that. We'll do questions at the end and we'll get to you. OK, Dimitri, let you go forward.
Very important topic. How much does it cost? So the watchers you create are free. The dashboards are free. Most importantly, there are no per instance, per database, per elastic pool, or per user cost. So that makes it quite inexpensive for larger environments with many resources, many users. What you do pay for is Custo cluster compute and storage, right? If you already use Custo, you can reuse an existing cluster. You might need to scale it up for additional load, maybe not. You can use free cluster for evaluations. Free cluster is free for at least 12 months, right? It has some limits, but to get started, that's quite sufficient. And of course, you can use real-time analytics in Microsoft Fabric, the same core engine, and then you just pay for Fabric capacity. If you use SQL authentication, you'll need a key vault as well. And of course, if you use cross-region monitoring, you will pay for some network bandwidth, but it's minimal price. OK, next, let's talk about the roadmap. So the top two items, alerts and SQL Server on VM, are really priority 0 for us. That's what we would like to get as soon as possible. We know that no monitoring solution would be complete without alerts. And we also know that a lot of our Azure customers run SQL Server on VM. So that's just a no-brainer for us to support. We also want to increase the number of SQL targets per watcher, improve manageability. You can already manage, create watchers and manage and alter them with ARM templates, bicep templates. But we will support PowerShell and Azure CLI as well. And then there is a long list of things under consideration, which we will do, at least some of them, but we don't know yet exactly what and when, right? So configurable data collection, so giving you the ability to pick and choose what to collect, at what frequency to collect. Improve monitoring of large estates. So for example, instead of adding each target one at a time, you could say something like, I want to monitor my entire logical server or my entire subscription, my entire resource group. So things like that. Extended events. We do want to collect extended events. Again, no-brainer. DMVs give us a lot of data, but the extended event give us even more. And then a long list of other things. So our request to you folks is to give us feedback. What is most important for you, right? So again, please look at documentation. There are details on how to give us feedback. And please tell us. Or if there is existing feedback item, please vote on it to help us define the priorities. Next, timeline. So we've been in private preview since summer of last year. And I just want to use this opportunity to say big thanks to all of our private preview participants. Some of them are in this room right now. You have all made Database Watcher much better with your feedback. Thank you. We are in private preview today. General availability is tentatively planned for the fourth quarter of this calendar year. I say tentatively because this is really will be driven by your feedback. We want to make this ready to go. We want to basically deliver a mature, reliable monitoring solution. So that's why we need your feedback. And then, last but not least, documentation. So all of the documentation is available at this link, aka.ms DB Watcher. The feedback link, aka.ms SQL feedback. This is the usual standard SQL feedback site. Just use it and put Database Watcher somewhere in the title, and that's how you'll find your feedback. If you prefer to just send us a mail, please feel free to do so, dbwatcherfeedback@microsoft.com. All right, and that brings me to the end.
Dude, man, that was awesome. But make sure that the link to the deck is up here to the right with all that in there. DB Watcher, the link. So, Dimitri, like, is your mind blown, or can you take some more questions?
I'll take some.
OK, he'll take some. So, Grant, you had a question.
So obviously, it's using Query Store, and so you've got to have data collection enabled on Query Store. Mm-hmm. Are there any other requirements inside of Query Store in the individual databases that are running that would negatively or cause problems with it?
No particular requirements. It's how you configure a Query Store. If you want all queries, you have to, of course, set the Query Store collection to all. Otherwise, it will just collect what's in there.
Awesome. Right here.
Hi there. At the moment, it's not possible for Query Store to capture any workloads on replicas.
OK, great
Can't
question.
see any individual query metrics. Does DB Watcher get around that problem?
So once Query Store on secondaries is supported, we'll collect the data as well. Because remember, Query Store on secondaries sends data back to the primary, so we just collect whatever is in the primary.
Is there a timeline for that?
Not yet.
OK.
Not yet.
It is actually currently under private preview right now to get that working. And under preview to get rid of the trace flag in SQL 2022. So I continue to push the team hard to get rid of that. But yeah, it's coming.
If you have multiple divisions under a single tenant, is it possible to segregate subscriptions to different Custo?
Absolutely. Yeah, okay. Yeah, so you have actually multiple options. You can put multiple databases in the same Custo cluster to share resources. Because in Custo, you manage permissions at the database level, not at the cluster level. So you can assign different permissions on different databases. Or if you want to segregate this completely, you can just create multiple Custo clusters and that segregates network connectivity as well.
But for you, Dimitri, you're collecting data at a database level, right?
At the SQL database level.
At the Custo database level.
Yeah, so everything goes into a particular Custo database.
Each Custo database has a watcher collection.
Correct. Correct. And then you can create multiple watchers with different Custo databases for different subsets of your SQL estate.
Other questions? Yeah, go ahead. You went online there.
Sorry, you may have answered this. Can we monitor KQL database in Database Watcher?
Can you monitor a KQL database in Database Watcher? So, not yet. This is SQL only, but it's an interesting question. I admit we haven't
That's a target, huh?
thought about that, but technically it's a target, yes. So, you saw me show some KQL monitoring queries, so nothing stopping us from collecting that and ingesting back into a Custo database.
But in addition to that, quick question, you showed in there, you can actually, as a customer, monitor what you're querying, correct?
Correct. So you see all of Database Watcher queries on your SQL databases. And you also see all of the dashboard queries in the Custo query store. So that show queries, you see.
Awesome. Okay. Another one.
Are there any known issues so far?
Are there known issues so far? I mean, you've been through private preview, Dimitri, but like, where do you stand right now?
Well, to be fair, we do have some known issues there documented. It's the same documentation. Yeah.
Okay.
So take a look. I don't think it's anything major, but take a look. And we'll keep that updated. As we find any new issues, we'll put it there. As we resolve them, we'll
If you give me any comfort level, like I pounded the heck out of this thing, getting ready for this conference, and it worked flawlessly, quite frankly. Yeah, next question in the audience, going back here, okay.
One question is there any overhead of running SQL, regular SQL to queries instead of QQL?
Okay, so
is there any overhead?
So any overhead querying this data into SQL, right?
Yeah.
Querying C-SQL in the Custo cluster.
Not really. So there are some limitations because remember, this is not SQL Server on the other end of this connection. It's Custo, right? So it supports SQL emulation. It doesn't support every single construct we have into SQL. So you will find some limitations, but all of the basic common queries work.
Okay. And another question: is there any audit data you're gathering?
Auditing in Custo or auditing on SQL?
Audit data about the SQL servers.
Well, you can just turn on auditing.
So
auditing what you're querying.
Who is running which query on the database?
Okay, so in other words, can it monitor, can it audit data? So we intentionally didn't do it because there is already a generally available audit feature in SQL Server, so that would be a duplication of effort. So yeah, just use that.
Okay. Got a couple more minutes. Any last questions? Been a great audience. Thank you. Stephen, have you got a question?
Yeah.
You're allowed.
Are you going to support deadlock graphs? Are
Sorry?
you going to support deadlock graphs?
Can you support?
Deadlock graphs.
Deadlock graphs.
Deadlock graphs. Okay,
deadlock graphs.
We collect a deadlock perf counter, which is just a counter. Graphs, no, because you only can get them with extended events. And we need extended event collection for that.
But you'd like to, at some point in your map, look at extended events, right?
That's on the roadmap.
Okay. One more, maybe. Right here in the front.
How many targets per watcher?
How many targets per watcher?
Like
Great question. So
yeah.
at the start of public preview, it's 50. We'd like to increase it. By GA, you should expect more. You can create multiple watchers. If you have a large estate, you can create multiple watchers to monitor subsets of your estate. And all of those multiple watchers can use separate Custo databases, or they can use a single shared Custo database as well. So you can solve that problem by just kind of sharding your estate across multiple watchers.
Okay, right here.
How much historical data does it keep?
As much as you want. So you set retention. By default, it's 1 year on a Custo database, but you can set it at the database level or at individual table level as well.
Guys, thank you so much. You've been such a great audience. Dimitri, again, is going to be here tomorrow and Saturday, and he's really serious about this. He doesn't want you just to ask questions. He really wants your feedback about looking at this and see what you'd like to collect, more feedback. Dimitri, thank you. Such an amazing job. Thank you all so much for being at SQL Bits.
Thank you.